Okay, cool, awesome. So for today's system design, I would like to design a platform like Leetcode. Okay, so this is a platform
Leet.
where we are able to, we have a client, a web client, let's just say, and the user is able to upload a piece of source code, right? And we need to be able to, run their source code, check that the answer is correct, measure some characteristics of the code like the runtime and memory usage, and then put them on a leaderboard.
Okay. Verify runtime, mem usage, and then leaderboards. Okay. Um, okay. So essentially, we just have a web client, so they can upload source code, and then system actually winds up running that source code, verifying that the answer is in fact correct, and also checking the runtime and memory usage, and then also having a leaderboard for. Do we want separate leaderboards for like runtime and memory, I presume, or like
Yeah.
what's
So we have different problems, and each problem will have a separate leaderboard for the runtime and the memory.
okay? So per problem, um, leaderboards or runtime. Right.
Yeah.
Okay, cool. So, uh, functional requirements are more or less there, I think. Let's talk non-functional requirements. What kind of, how many daily active users are we looking at?
So for platform leak, we're looking at about 1 million.
Okay, so we've got about 1 million daily active
Mm-hmm.
users. Um, am I okay to assume that folks are solving like maybe one or two questions a
Yeah,
day,
that's fine.
or like, okay, so one to two questions per day. Now, if I know anything, then I know LeetCode source code is actually fairly small, like maybe I don't know, a couple kilobytes per request, because like it's like one or two one thing of source code.
Yeah, you can assume that. You
Um,
can assume that. So that
I can
sounds
assume
about
that.
yeah.
Average of 1 kilobyte source code per upload request. Um, are we more focused on, let's see, I remember there being like availability and then data consistency that
Mm-hmm.
we need to worry about. Which of those two are our primary concern?
For this one, it would just be availability.
Okay, focus on availability. Okay, non-functional requirements. Okay. How's that looking for non-functional requirements so far?
That
Anything
looks
I'm missing?
about right. One thing I will like to maybe also call out is that about the leaderboards. People will oftentimes look at the leaderboards many times a day because they're interested in
Okay.
they're interested in who scores the highest.
Okay. So leaderboards are frequently visited.
Mm-hmm.
That's actually good to know. And then, but are so like let's say how many times are people looking at the
Let's
leaderboards
say
like
10
per
times
day?
per question they submit.
Okay, 10 times per question per day per submit. Okay, wow. Um, that's what? So per question per day per submit. So if we have 1 million daily active users, they're answering about one to two questions per day on average. Um, and then if we're checking, so that's like 10 million
Yeah, we can.
leaderboard requests. So that's 1 million daily active users times one to two per day, or yeah, 10 to 20 million. Okay. So going forward, what exactly do you want me to focus
So
on? In terms of like, because I know, we could go more into like the API
Mhm.
design. We could go more into like how are we actually going to make this available to work? Like, what do you want me to focus on
Yeah,
here
so
primarily?
the first thing I want to focus on is there's kind of two parts to this question, I think, right? The first part
Yeah.
is about making the client functionality work in terms of the code submission, and the
Right.
second part is about measuring runtime memory and the leaderboard system. So I would like
Okay.
to first sketch out we don't need to go into detail, but I want to know what API requests there will be. Like don't need to go detail what the parameters are, but I want to know what APIs there will be for both of these parts, and then I would like to
Mhm.
start sketching out a system design for the first part, for the code submission.
Okay. Um, so okay, so reading that back, so we want to have so we want to focus on the code submissions and then also, how that stuff runs. And then we also want to focus on the so we have essentially three things that we want to focus on if I understand this correctly. So we have the code submissions, we have the verification of the runtime, or the complexities, I guess, and we can factor in both time and space into that, and then the leaderboard.
Yeah.
Cool. So, code submissions, I think we can probably just do get and post for those. Um, I don't imagine people are going to want to delete these submissions, so we'll look at getting the submissions, also looking at posts, or no, get all submissions for a user. We can also get submissions for a problem. We don't want to worry about solutions. I suppose I know Leetcode
Yeah.
itself has a solutions feature, but I think we can just worry about
Yeah, that's not in
giving
scope for our problem.
submissions. That's on scope. Cool. So let's create a new submission. And then what I'm thinking is, considering like the verification of the runtime and stuff like that, all kind of happens in tandem with the code submissions. Like once a submission is created, it's automatically evaluated. So I'm thinking there might be kind of like a chain there.
Hmm.
Um,
I will say
so this
that
is more of a
we probably
back end.
don't for these two we don't need to focus on as much. Also, I'll put these as optional. Okay. And the reason is
Okay.
just because
Uh,
the feedback mechanism here isn't that important. The most important part for the
okay.
code submission is that the user can submit a piece of code and get feedback if it's correct or not. That's kind of the baseline
Okay.
functionality.
Okay. Cool. That's very good to know. So, and then the leaderboards. So we basically just want to kind of get the highest scores for particular problem. Whatever that looks like, we'll work that out. So problems would probably be referenced by either an ID or a slug. Thinking, okay, let's look at the actual. So actually, before we move on to data model, how's that looking for the API itself?
That's fine. Yeah, that's fine.
That's fine.
We can move on with this for now. Yeah.
Sure. So the data model itself, we're going to want, obviously, we need users, um, we need questions to, or I guess problems to actually ask. We need submissions, and then I guess we have the leaderboard, but we can probably just use the existing things for that. We can probably just like map submissions into questions and problems, display that on a leaderboard, and that'll be it. Let me see here. User model, so we'll just get name, email, probably just some kind of unique ID for the database. Considering the data is fairly structured here, I'm thinking we can use a relational database. I don't know if you would disagree with that.
No, that's fine. We can go with that.
Cool. Questions and problems. So they'd have unique ID. Can also probably say we'll have a slug for them for the sake of, because I know in actual Leetcode they have like that a slug for a question, so like just the lowercase with dashes in the
Hmm.
middle,
Yeah.
and that'll just help quickly and uniquely identify a problem without having to go through IDs
Yeah.
and
Yeah.
whatnot.
That's fine.
Uh, and then name, um, description. I know that we're probably going to need some constraints as well of some kind. Um, And then that might be, um, yeah, that might
This
be
this is
either
something
like
we don't need to
JSON
worry
form.
about too much right now. The only information that we
Okay.
need on the client or even internally for the problem is that we need to have a string description to show the user and IDs and names of that. That's all fine, right? And then
Right.
internally we need to have you can have, for example, a configurable timeout for the time,
Right.
so something like that could be fine. And that's all we need. We don't need to worry about anything else for now, unless you think there's something needed for the problem. But in terms of what the customer needs, that's all we need.
Yeah. I mean, actually, if we're running that server side, I know we'd probably need like some test cases.
Yep, some test cases as well. Yeah.
Yeah, some test cases. And then submissions, we can probably just go with a unique ID. And then we'll also need to map solution to problems. And then we can assume these are just foreign keys. So we can just retrieve those later. And then the actual source code. Can probably also just store the runtime and space taken. Okay. Oh, and then I guess memory bound. Probably do it as well for questions and problems. Okay. How are we looking on this front?
Yeah, that's definitely enough to move forward. Let's move forward.
N-
One thing I want to highlight here is that, again, we're trying to focus the high level system design first of all on just getting the submit flow working. So we want the customer to
Just getting the
submit
flow
source
working.
code. So they want it to have to pull it, so to read the problem, right? They have to get the problem. They have to submit the code, and they get feedback on if it's correct or not. That's kind of that. Like this is the baseline function that
That's
we
a
want to
baseline.
make first. Yeah. So let's just focus on that.
Cool. All right, that makes sense. So we want to focus on the submission first and foremost. Okay. So let's focus on that, and then we can probably just extend the system later. Okay. So let's say that we have some kind of submission service, or I guess like call it submission API. And whether or not this will get folded into the main API, we'll see in a second. So web client, obviously, they're going to make a request to that submission API whenever the user wants to upload their code. Alternatively, we could also need to get some kind of a problem. Oh yeah, we'd also, yeah, I'm realizing that. So we'd need, so user would need to,
Mm-hmm. Okay.
so initially the user would actually need to fire off a, we need to fire off a request to actually get a problem, and then we'd probably be able to have some kind of submission API and then map, and then within the request itself, we can map the submission problems. And then, let's see, so submit a solution. So client probably runs the, probably writes their code on the web client. They do their thing. Once they submit a solution, we hit the submission API, and then we're going to get to a point where we need to do a few things. So first thing, obviously, we need to actually execute the code.
Mm-hmm.
For this, I'm probably going to have some kind of containerization system. So this way, we'll actually be able to execute the code
Mm-hmm.
in an isolated environment. Because what we do not want is we don't want code actually executing on the server.
Mm-hmm. Yeah.
This is, like remote code execution. It's the bug to end all bugs, right? It's not something you
Yeah.
want in your system. So we're going to want to keep that isolated. And then I'm thinking, okay, so we want to focus on availability rather than consistency, I suppose, right? So if I'm thinking, like, would it be better to, like, once the submission is fired off, store that, store the record of like, hey, there was a submission that happened here, and maybe there's like some kind of status check, or
Mm-hmm.
do we want to save the submission after it's run in the container, and then, if the container fails, we just kind of like tell the client and then not even record it.
Well, the client definitely needs to know if it. I mean, the client needs to have a result at the end of the day. So even if it's an error, for example, the client should know to rerun it.
Yeah, okay, that's what I'm thinking. And then, if we do somehow get an error, then we can just kind of result in it. Oh no, wait, no, if it's a submission, if it's an actual proper submission, then they'd probably want a record of it failing, because that failure might be to either a timeout or timeout or running out of memory. So in that case, so let's get a database system up and running here. I'm gonna black box this for now because I know we're gonna worry about scaling it later, but I'll just black box this.
Mm-hmm.
That. Cool. So submission API. So what's gonna happen here is thing number one, we're gonna probably record a submission as happening. No, we're not. We're gonna do thing one and thing two in a couple of different orders here.
Okay.
So thing number one, we're actually gonna execute the problem, and then thing number two. So like this would probably involve like spooling up a worker thread or tracking a message queue. Oh, okay, no. I'm overcomplicating this already. So let's just get something quick and dirty out the window. So first and foremost, we actually request. First and foremost, we actually run the code. Second of all, we're going to store the result of that submission.
Okay.
Of that submission. Now I know this is probably going to wind up with some kind of issue on like, okay, what happens if the submission fails for something that isn't related to the actual source code they submitted? Like, let's say the container just stops responding altogether.
Yeah.
This could go either one of two ways. This could go one of two ways. Either we, one, use a message queue in some kind of way, and then maybe pair that with WebSockets. Or two, we have a dedicated worker thread.
Mm-hmm. Okay.
And then whenever we need to actually spool up kind of these containers to actually execute the code, then I'm thinking, that said though, if we're looking at 1 million requests, like if we're looking at 1 million code submissions per day, that's going to be a lot of threads. That's like, what, 1 million divided by, I don't know.
It is a lot,
yeah. Yeah, so it would be a fair amount. So unless we can handle like, so that would be like 24 times 60 times 60 times, yeah, so we have 24 hours in the day, 60 minutes in an hour, 60 seconds in a minute, so that is going to be 24 times 3,600. It's going to be, yeah, pretty easily, probably...
You can use a calculator if you want. I don't mind using calculators.
Oh, yeah, okay, that's fair enough. I'll just run that through Python. The OG of calculators. All right. So it's less than 100,000. Like in terms of just like seconds per day that we have to work with. Mm-hmm. So if we're like, that's easily like multiple requests per second. So that's like what, 1 million. Oh, nope, that is not have that correct. Oh, okay, so that's actually about 11 requests per second. That's actually not that bad for worker threads. I'm gonna be completely honest.
Mm-hmm. Yeah.
Like that's not realistically that bad. Like obviously if we wanted to scale this up to say like 100 million users, then I'd probably start looking into message queues and WebSockets, but for the time being, I feel like just spooling up a worker thread works fine. Like, do
Yep.
you
No,
disagree with
no,
that?
that's totally fine.
Cool. All right, let's operate on that. So, essentially, so we just kind of spool up a worker thread, and then, you know, API kind of goes off and does its thing. Now, I imagine that when we do spool up this worker thread, we're going to have it so that I think we're still going to wind up using WebSockets anyway, because what I'm thinking is when this worker thread, stops executing, right? So let's actually move this over here then. So once this worker thread stops executing, it's going to send a response back to the client, and then that response will probably be through some kind of WebSocket. So, and then that'll indicate, whether we had an error, whether we had a successful run, whether, something else completely burst into flames.
Mm-hmm.
Client will know that way. So I think what we'll do instead is we'll have this going here. So for the submission API, so we'll just, so one bin up worker, then that worker will actually run the code. And then, so that worker will then run the code. Once that code finishes, we can probably just have the worker store the result directly. So,
Mm-hmm.
yeah, I realize this is getting a little bit chaotic, but that's fine.
That's fine.
We're just kind of moving quickly. And then we can probably send the results through a WebSocket. Okay. So yeah, we store the results. And then for the problem API, this is just fairly simple. This is just going to be getting the problem. This is obviously considering, just working with problems and then submitting solutions.
Mm-hmm.
So, all right. That, yeah, that looks about it for as far as the submission stuff goes.
Okay.
And then obviously, IT security, those guys can worry about the containerization and how
Yeah.
to lock that down. But for the sake of system design, I think this is looking pretty good. What's your take on this?
No, I'm in agreement there. I think the correctness is there. Let's move on to the leaderboard then.
Sounds good. All right. So for the leaderboards, we're going to actually probably have to go through. Yeah, I'm thinking we can probably have a separate leaderboard API because this would be, going through the. Yeah. So, yeah, getting the highest scores for a particular problem. So we actually did do that. And then, yeah, so we have a web client, and so whenever they want to get a whenever they want to get the leaderboards for a particular problem, they can just use the leaderboard API. We can just have that separate because I imagine that'll probably be distinct from the problems and submissions. Now, you mentioned that the leaderboard is fairly popular.
Yeah.
So we're looking at like 10 times per question, and then 1 million daily active users, like 1 to 2 questions per day. Like we're looking at in the scope of like 10 to 20 million leaderboard requests per day.
Yeah.
So let me see how many. So that would probably be on the order of like 100 requests per second. That's not something that we want to use database hits for. So I'm thinking we're going to want some kind of caching solution. So let me think this through. So I imagine that can we assume that there are going to be some problems that are more popular than others?
We can assume that. Yep.
Okay. So in that case, what we can probably do um, is, once a problem is requested, then we cache it.
Mm-hmm.
So like, for instance, and this is like assuming we get a cache miss for a particular problem.
Okay.
So like if we're using something like Redis, right? We just have the problem ID, and like obviously, some internal part of the API would probably map problem slug into the problem ID. I'm just gonna kind of black box that for now, and we can get into that detail later. Um, so we go from uh, key no ID, and then we map that to the actual problem plus submission. So what I'm thinking, right, is we just do so we can probably like whenever we have a database, and then we can probably use the last modified, right? So
Okay.
we can probably do last modified, and what that's going to do as part of the key is I'm assuming this is kind of assuming that our database has last modified in as a default. But what that does is if we have an outdated problem for which we have submissions.
Mm-hmm.
Oh yeah. So I'm thinking like I'm imagining somehow we could store the last modified, and I'm thinking this might be, or maybe like last submission. There we go. That'll do it.
Okay.
So I'm thinking if we store that as the last submission, right? And then whenever we're storing the result, we update that last submission. This would allow us to actually have a cache where, as long as the problem that we have hasn't had an updated submission, then we'd get a cache hit and we'd be able to get that problem and all of its submissions.
Right. So leaderboards. How are you envisioning the leaderboard being? So what is actually shown to the client?
So what I'm thinking is if we're looking at a particular problem ID,
Mm-hmm.
right? And then, so obviously like getting the leaderboards, so we're looking at a particular problem. So I'm thinking then that we would probably have two separate cases for runtime
Mm-hmm.
and then memory.
Yeah. Sure.
And then also, oh, no, runtime, memory, and then I think language as well would also probably be.
We don't need to worry about language for now. Yeah.
Don't need to worry
Yeah.
about. Okay, cool. That's good. So yeah, we'd have separate leaderboards for runtime and memory.
Mm-hmm.
What I'm thinking is, considering every problem is going to get runtime and memory anyway, we would probably want to figure out something to do with like pagination, right? Because that way we would be able to
Okay.
kind of get the yeah, so that way users wouldn't be like absolutely overwhelmed with the level of data. So wait, okay, I'm realizing this is kind of at odds with each other regarding the caching strategy and then also having like a page. So
Just to back up, the original question was like what is the client seeing when they get the leaderboard API?
right, okay, yeah, sorry, I kind of lost track of that.
Yeah.
So the client, what they're seeing is so we're not worried about language right now.
Mm-hmm.
What the client is actually seeing is a list of submissions. So in one column we might have ordered by best runtime, and in another column we might have ordered by, I suppose, by memory. And then they'd be able to kind of like swap between the two, something like that. I think, or what we could do is so I guess what I'm envisioning is like we have a column, we have like basically a table,
Mm-hmm. Yep.
right, on the client side, and it has all the submissions, and then it has the runtime and the memory usage inside, like as separate columns,
Yeah.
but they're all in the same entry. And then the user can probably go ahead and say sort by, okay, let's sort by runtime, or let's sort by time complex, or let's sort by memory usage, right?
Okay, I see. So what's the default? So what's the default ordering when it's shown to the client first?
Usually people think in terms of runtime,
Okay.
so I'm gonna say a runtime is
Okay.
first. So I think we could actually cache the submissions in order of runtime, actually.
Okay.
So like we can use that cache in order of runtime because that's gonna be our default.
And
So
and you mentioned pagination, but how many submissions are you caching?
let's just say we can cache. Yeah, that's a good question. So how many submissions am I caching? I'm thinking we'd probably want to cache, I'd say the first 10, or no, the first let's say the first 50.
Okay.
And then if there, and then obviously as more submissions go on, you'd have to like explicitly request
Uh huh.
um different pages. So I think those are okay for database hits, but for the sake of like let's say the top 50, um we shouldn't have to worry about that. And we like, because I am, what I'm guessing, right, and you can correct me if I'm
Mm-hmm.
wrong on this, what I'm guessing is that users are probably going to um, request like just the first page of the leaderboards just to see what's there, and then maybe also their location in the leaderboard.
Yeah.
um and like for the latter, i think um I think getting that database hit, that cache hit on the top 50, probably going to be a little bit more important than
Mm-hmm.
getting a cache hit on an individual user, because you never like, how many times is an individual user going to check the leaderboard in the day?
Only for the problems they submit, just once.
Right,
And so they
right.
don't
So it's
change. Yeah.
once a day, not something we really need to worry about caching. So I'm
Mm-hmm.
thinking just getting that top 50 result cached per problem, and then for the last submission, obviously, in case that updates things. So I think so we realistically only cache the first 50.
Okay. Cache your first 50. That makes sense.
Yep. And then I imagine, the page itself, we can go like up to 50, maybe even. And then for pagination, obviously, this will kind of determine, whether we go either straight for the cache, if they're just getting the top 50
Mm-hmm.
result, or, if they're just getting, maybe results among their friends. I don't know what kind of specific APIs are going to be going on here, but there's probably some level of parameters that might happen here. But the key thing is, we're going to want some level of pagination where, if they request, say, page two, or they just request their own position in the leaderboards, instead of going straight to the cache, because there's no point in going there, then we'll just do a database hit, and then that'll probably, for our purposes, I think that should be okay. What's your take on that?
I think that makes sense at a high level. I want to hear a little bit more about your cache eviction strategy, if there is one.
Cache eviction strategy. That is a good point. So once we're looking at problem IDs and last submission, I'm thinking there are two ways we could go about this. Um, One is we could just have like a 24-hour expiry. So let's say, oh, actually, timeout, an expiry timeout. I think what we can do is, let's say, every hour or every 24 hours. Thinking, because again, some problems are going to be more popular than others.
Yeah.
Um, Now, when do you expect the popularity to like fluctuate? Is it on an hourly basis? Is it on a daily basis? Like
I'd say
how's this
what
working?
every day there's a new problem, let's say, and it's the most popular on the first day, and it follows a power curve down.
Okay, follows the power. Okay, that's actually super handy. So what I'm thinking is a 24-hour reset. Let's say at midnight Pacific,
Mm-hmm.
for the sake of standardizing this. And then what happens is we clear out the cache at midnight,
Okay.
and then what that does is that'll just kind of, okay, we just wipe those like cached problems and submissions for the leaderboard,
Mm-hmm.
and then we start fresh. And then if that problem still remains popular, that's fine. there is still going to be that, one request that's slightly slower. But if that problem is still as popular as the day that as the other day, then that's fine. As long as we still have those top 50 submissions, I think we're in a good spot.
Okay. Yeah. No, I think that's fine.
What's
Yeah.
You think that's
Yeah.
fine? Okay. Cool. So, so we've got about a kilobyte of source code per upload request. Oh, you know what I'm realizing?
Yep.
The source code itself, that won't be great to store in a database.
Okay.
So instead, the source code, what I'm thinking, maybe let's store the source code URL. Because if we have, let's say, like an S3 bucket, right, we can just kind of like retrieve the source code from that.
Okay. Yeah.
If we ever need to like get that. So let's say, yeah, or sorry. So let's say we have an object storage somewhere. I'm not going to necessarily use AWS S3 because I'm not super familiar with like the nuts and bolts of that. But I imagine there's some degree of access control. So
Yeah.
if people want to do like private submissions, they can. But that's again, that's an if.
Sure.
So, yeah. So I'm thinking for the so I'm thinking we might also just have the result storage kind of branch off from here, and then pop that in there, and then.
So we're saying that the worker thread is storing the source code in the object store.
Yeah. Well, the worker thread would need to have access to the source code.
Okay.
Right.
I see.
Yeah. Yeah. So, so yeah, you store the result, and then the result comes with the source code URL, and that source code itself is getting saved into object storage.
Okay.
And these are all kind of part of the same steps, which is why I just have that one there. And then for the leaderboard API, we can also just do a thing where we effectively kind of wrap around here, and this is a little chaotic, but we kind of just wrap around here. Okay. For the sake of this.
Right. So leaderboard's also what's going on there? Is it reading or writing to the object store?
This is going to be a read,
okay.
Actually. So yeah. Thank you for asking that. Because I imagine if somebody goes like, "Hey, this submission is like kind of insano for runtime," they're probably going to want to get the source code for that.
Yep.
So we can just have the leaderboard API do that, because like again, we're just storing the object URL, whether that is in the cache or in the
Sure. Yeah.
Whether that's in the cache or in the database, right? It's got a much smaller profile than the actual source code, so we can just have that in object storage, and then once we need that, we can URL, and then we're good. For unusual page.
Okay.
And then 50. Okay.
Yeah.
Okay. So that's for object storage, and that's just both to kind of maintain availability, because I imagine the object storage is going to be. Oh no, wait. No, I remember this from last time. The object storage actually might be better off if just the web client requests it directly, because then what might happen is oh yeah. So in that case, what we can do is something like this, where I'm imagining like the object storage as being like an external thing, since like seriously, who hosts their own S3 bucket, right? So what I'm thinking in this case is that we have once you get the results, right, then we can just post the then we can just have something to like post the source code of the submission, right? And then that way that'll avoid that internal network request to something that might take a hot minute to respond. So 5 save source code. And then never mind, I just realized if we're writing it only once, then that shouldn't be as big of an issue. Never mind. My initial solution was fine. What am I doing? Because if we're only writing the results to the object storage, we're only doing that once, which is fine. However, if we're asking someone to read the source code, and we're asking basically everybody to do that, we don't want the leaderboard API to get hung up on grabbing stuff from S3. So we can just say, hey, here's the URL for the source code to the web client, and then they can go retrieve that themselves.
Yep. Okay.
Okay.
I'm gonna give a 5-minute warning here, so we can wrap this up soon if you got nothing else about this spec.
I don't really have anything else about the spec. I mean, we could have probably gone into like database optimization, but I'm imagining there's probably going to be some level of like a sharding strategy. So if you're happy leaving it off there, I'm happy leaving it off there.
We can leave it off there, but maybe one thing I will give you a chance to elaborate on is you do assume some order of sorting, ordering. How are you planning to do that?
That's a good question. So I'm thinking that whenever we actually I forgot to mention, so whenever we're actually at some point we are going to have to like write this to the cache. So whenever our leaderboard API, whenever we get a cache miss, and it is for that top 50, right? Yeah. So this is kind of the only time this happens. When it is for that top 50, we run a sort on the runtimes, and then so we essentially run a sorting algorithm. That's going to be like n-log-n if we're using something like merge sort, and that's just going to be on the runtime field. So yeah, and we have a so we already have a runtime field in the submissions data model. So we can use that and just kind of sort by that. I'm imagining it's probably going to be some like number value depending on the database you use, probably Unix timestamp if I had to hazard a guess. And then we could just do a straight sort by numbers on that. Lowest one wins.
What's the and you mentioned and what's the complexity of that? Are we sorting the because one thing you didn't say here explicitly, but I assume is the case, is that we're partitioning the submissions by problem, right?
Yeah, we are partitioning the submissions by problem.
Right, and in that case, so you mentioned this. So the complexity of sorting is n-log-n, which is generally true. Why do you think that is true for this case?
Actually, I guess if we're sorting this thing using because I'm imagining that we're comparing submissions of a given problem to each other.
Yeah.
And then the reason why it's n-log-n is because there's actually like a lower bound on sorting that is omega n-log-n, and then there's a proof for that that's based on a comparisons that I'm not going to get into. But yeah, n-log-n is going to be the best you're going to get as far as the sorting algorithm goes.
Okay. Okay, let's call it here. I think that's about it for this design.
Sounds good.
Let's go over some feedback then. But as I always do, open up with how do you feel you did? Anything you think that was good or bad?
I feel like the time management was a bit better than last time. Or at least that's how I felt. I didn't feel like too rushed going into that last sector of it. That said, I could be entirely wrong. I'm not super great at being aware of how much time is going on.
Okay.
But that said, I think I was also able to kind of translate some of the lessons learned originally. Even sometimes necessarily when I guess I did forget about that one pattern we mentioned a while ago where there was we had like that message queue
Hmm.
of
Yeah.
of uh, merges. Um, that said, I think considering we're working with like maybe 11 requests per second, I think the work I know we went over that initially, and like we said,
Yeah.
okay, it's if it's about 10 requests per second, worker threads shouldn't be too much of an issue.
Yeah. Yeah.
So that said, if we want to scale that up, I think we'd probably want to look into that message queue solution.
Hmm. Okay.
Um, and then I also realized I learned from last time about the external object store
Yeah.
and how to avoid that bottleneck
Hmm.
with the internal network. So I think overall I'm pretty happy with that.
Okay. Cool. Let's talk about it. Let's talk about it.
Sure,
Um,
100%.
couple of good things off the bat. Let me put my notes up. Couple good things off the bat. Good pacing today. Right, good pacing today. That was good. And part of that good pacing was because you were checking in frequently with the interviewer, and you were asking reasonable questions to to kind of leverage that. Right. So asking
Okay,
about
awesome.
how's the pace, asking about is this, can we move on, asking about the API detail we need to go into, that kind of stuff is good for like questions that aren't about the actual problem are okay to ask because that's just meta level stuff the interviewer can help you with. So that's good. That was a standout over here. Um, let's get into some more technical details then.
Sure.
Yeah, so the client, the non-functional requirements are all fine. One thing that I will say that isn't really a like a miss, but something you should have probably asked was, like one of the uh, characteristics missing from your non-functional requirements is like how many problems there are on the site, because that would affect your
That
caching
is a good point.
strategy.
Yeah.
And
That is, yeah, that is, oh, I can't believe I didn't think to ask that. Yeah, that's a good point. That's a good point.
yeah, so that would for the reason that's not really the end of the world is because one that issue isn't in the world because for the caching strategy we can talk about this a little bit. Um,
Yeah.
like all the signs in this problem pointing towards using a least frequently used cache, and why that's the case is because as the problem spec you say top 50 problems, top 50 submissions per problem. And I gave it to you. I said there's a power curve, and in reality, it doesn't really matter what it is. But regardless, at the end, you kind of still talk about the same thing where you want to reset the cache and let the most popular questions bubble up, per se. This is
Mhm.
essentially, and you're doing this manually, but this is essentially what a least frequently used cache does, right? Where it just, it caches an object, and the object in this case, right, is a problem plus its top 50 submissions. That is an object, right? And
Okay.
then you just toss out the objects that aren't requested as much, and that would be
That's super
agnostic.
interesting.
That would be agnostic towards how the distribution of popularity, and that would be also agnostic towards the time of the problem. Right, there could be like a famous problem that's released a long time ago that people still want to do, and that would just never get released
Right.
from the cache because
Because
obviously,
everyone's
yeah, it would
doing it.
just always be requested.
Okay. So least frequently used hash. That's actually super interesting. I never knew about that until now.
Yeah, so that's something you can. I mean, you probably heard of like least recently used or etc. So these are all eviction strategies, right? Because when the cache
Those
fills
are all
up,
fictions.
you have to evict something, and so what do you evict? So you
Right.
evict, in this case is least frequently used, which in this case is least
Okay.
frequently read, right? So that's what use means in this case. Yeah, so that's
Okay. Well, either way,
yeah.
still, still, yeah. So yeah, I was kind of doing that, except not. So I
You
guess,
you would have had the
um,
same outcome because you still reset it, but that would be more error prone and it would be slower because you would only reset every 24 hours. So if the frequency
right.
updated in the middle of the day, that would not be caught. That would not be that it would be a misses for the entire day. If it, for example, you reset the cache and then the next day was completely different.
Yeah, that makes sense.
Um, okay, and then while we're in this area, we can talk a little bit about the leaderboard. So leaderboard in general, the API design's fine. One thing I will say though about the object store, and this is something you definitely did catch, is that availability for leaderboard is both a function of the leaderboard API and the object store, and
Okay.
it's more of a function. There's a more heavy weight on the leaderboard API than the object store, because remember, for the way our client works, you can only, the way you described it actually, is that you can only view the object store at the leaderboard already loaded, right?
Hmm.
Because that's how you request a submission because that URL is part of the leaderboard like a return request, right?
Right.
So in this case, having the client redirect from the object store doesn't actually add any availability because the bottleneck is still on the leaderboard API.
Bottleneck is still okay. Good to know.
Right? Because if the leaderboard API fails, it doesn't matter that you can read the object store. You don't know what the URL is.
Right.
So this one, in this case, got to be careful in that, yeah, this works in theory, but actually the way the product works, it doesn't do anything. Right?
Okay.
Now, on the other hand, there is some merit to having the one you deleted actually, the web client write the submission directly to the object store. There's a bit of merit to that. And this would depend on how we're kind of, I mean, I'd still say this is not a good thing, but you could argue for it in that, you say, oh, the web client directly submits the what is it called, source code to a because you can say, okay, every user gets a pre-signed URL, right? And they know this and this is on the client. This is in the secret cookies, whatever we want to call it. Well, it wouldn't be the cookies, but it would be in the secret data store on the client. And so
it would be somewhere.
Yeah. And so and so the client wouldn't need to go to the submission API to get to get a URL because you would already have a pre-sent URL. And so you could argue, hey, because for the client to submit a piece of source code that doesn't require this submission API, that would be higher availability, and that would be objectively true. Now, what that would mean for the product, we didn't define clearly. Like, did we say is a system supposed to continuously scrape external submissions to that store to run to process? We didn't clarify that, but you could still argue that method at least would provide additional availability. So you got to keep in mind availability is both a function of the actual technology and a function of how the product works. So that's something to consider for the future.
Good to know. Okay, so so if I understand it correctly, so was my method better or worse than the one that you were talking about, where like you actually have that pre-signed URL?
Yeah. So is it better or worse? In this case, it's the same because that was not part of the product spec. If, for example, the product spec was that you must process all of the submissions, no matter their source, so they could be sent from the official web client, or it could be sent directly through API, like through like a some other third-party client or something, right? In that case, then there is merit to using the other system because if the client is down, or if the page load server, for example, we didn't draw this thing because it's not important, but the client's also the client has to first make a request to the HTTP server to get the actual JES and HTML to render to the client, right? So if that server's down, but the submission API is still up, then you would have a problem with the solution because you're reliant only on the web client. Right, so then it would be a problem. But because we said that we only have one client, that's not an issue, right? So, but be aware that could have been a follow up, right? That could have been a follow up. Okay, let's say we have 30-party clients now, right? Then what's the bottleneck now? Then you must realize that the weak link is now the submission API being the only source of submission.
Right. Okay, that makes sense.
Yeah. Okay.
Good to know.
Yeah, for sure. So another thing is what I have here. Math. You can use a calculator for math. Almost everyone will use it. But there are some things you should still know, like just memorize. Like there are 86,000 seconds in a day, just assume it's 100,000. And also the system, something for your quick math, is that you could just run to the nearest power 10 for all numbers. It doesn't matter. Just run to the nearest power 10 for all numbers.
Well, the thing about that was I was just trying to figure out whether that power of 10 was 100,000 or a million, because I knew it was in that ballpark, but it was like I want to have a bit more surety.
I mean, for these kind of things, you should just memorize that there's 100,000 seconds in a day, because all of the numbers framed to you will be per day, like requests per day, how many users per day. All these things will just be per day. So just memorize there's 100,000 seconds in a day, or just use a calculator. So that's kind of how that works.
Yeah, no, that's what I'm thinking I might do going forward, or just.
I mean, you could definitely ask, but generally speaking, people are hiring you for your ability to do mental math, so that's usually okay.
Fair enough.
Okay, so next thing we'll talk about is scalability. So of course this is not the concern here. You did the math, you found out that this is suitable for the requests we get, but keep in mind that actually the bottleneck here is not the number of requests we get, because the thing you're thinking about is how many workers can we spin up per second, and the answer, yeah, sure, you can do 11 per second. That's not a problem. But one thing you didn't mention is
the bottleneck is the containers.
Right. So the containerization is going to be a bottleneck because, first of all, you have 11 new containers per second, essentially, you're doing, right? In addition to that, but you also glossed over this a little bit, which is what does it take to spin up a container? Like, what does a container lifecycle look like, right? So okay, we need an image.
Right.
Where's the image from? Okay,
Mm.
let's say we're using EC2. Okay, whatever, right? So we have an image. We use a base Amazon what's it called? Enterprise. Like, oh, it's Red Hat one, Ubuntu one, doesn't really matter. So run this thing, great. It has to download the source code, so it has to have the code, right? Now the source code is only 1 kilobyte, but right, the throughput's not the issue. The issue is the latency. Where are we getting the source code from? From S3, great. Gotta have that system in place, right? All these kind of things we can like for this level of design we can kind of gloss over, but realize that if the question now changes to okay, let's say we go to 100 million, right? So now you can't use worker threads. You can have and you said we can have a queue. A queue would be great, but that still doesn't solve the problem of how do you organize the containers, right?
Right.
So that's going to be that would be the in this case that would be the number one bottleneck for this system.
Got it.
And
Okay.
I don't know if you realize that, but generally speaking, you should be calling out that if we scale it, this is going to be the bottleneck. This is going to be the bottleneck if we hit this and this many users, etc. If you can kind of pinpoint that, that would be kind of the best way to kind of talk about that.
Yeah.
Even if that's not an issue right now.
Yeah. I think what kind of my Achilles heel there was just, yeah, honestly, I kind of forgot about the containerization.
Okay.
Like, just being straight up,
Yeah.
I kind of like just set that aside, and I'm just like, if that becomes a concern, I'll probably come back to it.
Right.
But yeah.
Yeah. Well, one thing is always like the meta level stuff is you can do a bit more organization, right? So there's different colors you can use. You can use like little symbols. You can do a little draw on this to say, hey, come back to this later on, etc. So there's some things you can do to kind of remind yourself. But in this case, you probably just lucked out a bit. It didn't really matter. But some interviewers, when they ask questions like this, they already know in their head what is the bottleneck, and they want to see if you know it as well. So then the follow will be, okay, let's increase the number of users. What's going to break first, right? So that's
Right.
kind of number one follow up question. And when you practice these, if you ever do, that should be the question you ask yourself: is let's scale this up. What is going to break, right? So that's the that's the thing you can very easily test yourself on.
Right. Okay. That makes sense.
Okay, and the last thing I'll comment on today is about the database design. So we didn't do actual tables and whatnot, but I just want to comment on this. A couple things. First of all is the detail in the data model that you wrote is totally fine. But one thing you should always have, especially when you're doing something like a relational database, is for every table you should always indicate what the primary key should be, and you should always indicate what indexes you will have. So or like what partition, right? Partition indexes. And the reason that's
Got it.
important
Okay.
for this case, a couple things. I mean, so you indicate the foreign keys. I mean, it's pretty obvious that you have a unique key here, unique key here, unique key here, right? So we don't need to talk about the PKs. The primary keys are fine, right? But the
Yeah.
reason the indexes are important is two reasons. The first of all is you didn't actually say that you were gonna partition on the problem, right? Now in this case, it's pretty obvious that you will, but you didn't say that, right?
Right.
The second thing
Okay.
is that the partition and the index actually matters, and the reason it matters is because when you define our partition or you define an index, depending on what language you're using, I'll just say index because that's what SQL Server is.
Yeah.
You need to define what the structure of the index is, and a structure can also include a sorted index. So the right way to have the quote unquote right way to have defined a problem's index is to have a problem index, right? So your column is going to be so your index name is going to be on problem, but you'll have a sort object, a sort column on the runtime, and you would also have and we didn't go into this, but it didn't matter. But you would have an index for both the runtime and the space complexity. It would save you time that way.
Got it.
But so let's just say runtime, right? So and the reason this is important is because when and initially, let's say you have 0 customer, whatever, or very few customers, is that you can backfill this table very quickly. So you'll incur one in login sort operation when you generate the index. That is true. However, in the future, when you insert, so you generate this index exists, right? Now if you have an insert operation, what's my key doing? Where you have insert operation, it's only a login insertion.
Right.
And that is.
Oh yeah.
That is.
How did I completely forget that you can just like I think this is because like I've spent so long in like an algorithms
Yeah.
course like the last semester, but like I completely forgot that you could just order by a thing in a database.
Yeah. Well, it's
Like that's just the thing you can do.
yeah, but keep in mind this is very very unique because it's like order by is a SQL operation, but if you use order
Right.
by on a non-sorted column or a non-sorted table, or use it on a table with a non-sorted column as the sort by key, order by key, that is still a sort. That is still an login under the hood because it doesn't know the
Okay.
ordering, so
Right.
that would still be in login. However, if you use order by in a sorted index on the index that it's on the column that it's sorted on, in this case complexity, or on runtime, sorry, then it's actually well, it's O1 because it's already sorted. So it
Okay.
incurs no additional sort cost. Now, why is that important? That's important because one thing you didn't explicitly, like you actually said we didn't actually solve, is that you need to know the ranking of the current user. And so if you
Mm.
said, so if you want to get the rank of the current user, that would be O of n without a sort key. Right, that'd be O of n because you have to
Mm-hmm.
scan the entire table to find your user. Or right,
Mm.
and that's the best case. In reality, it would actually be in login because you would need to know the absolute rank, like the global absolute rank of the user among all submissions. So that would be in
Right.
login per problem, right?
Okay, and that's not
So
great.
that's why you would need a sort key on this one because then the entire table is always sorted and a rank of index will always be it would be in theory login time because to find a item in a sorted list that's login, but in reality that would be O1 because SQL will maintain a column order for sorted indexes. So for that kind of
Gotcha.
question, login or O1 would be both acceptable answers. In reality, keep in mind in real life, login is the same as O1. It's just the same, like actual milliseconds, because the
Yeah,
up
it's like
head
functionally.
cost, the
Yeah.
cost to make a transaction in a database, so far outscales the number of columns you have in a million, 10 million, 100 million SQL. It's just not even close. So
Got it.
keep in mind that the sort index here was the intended answer for solving the leaderboard problem.
Okay. Cool. I will definitely keep that in my back pocket for the future. That is
Yeah,
very handy to know.
yeah. Okay, that's all the notes I had.
Okay. Awesome. All right. Yeah. Yeah. Leo definitely will kind of keep that in the back pocket. It sounds like most of the issues here were either A, forgetting things exist like in the realm of
Yeah,
containerization,
yeah.
or B, kind of more on the technical front, like not knowing about the least frequently used cache strategy or the sort index on the database, for instance.
Yeah, I think it's some things you could definitely improve on with better organization. Some things you just didn't know of or hadn't thought of at the time, right? So,
Yeah.
I mean, different things. Like these are pretty common things that come up. So, with practice, it comes more easily.
Awesome. All right. Well, thank you so much for doing this, Leo.
No worries.
Really appreciate you hosting these. You're doing a wonderful job with these, man.
Thank you very much. Take care.
You as well.